Happy Fugio Friday. It's time for another update. This week I'm in sunny Vienna. I've got another two plugins for you. We're up over the 100 node mark now, although I've still got about another 100 in development that I'll be releasing over the coming weeks. This week we're going to look at scripting, which is on our way to sort of introducing, creating some visuals, which I know a lot of you are all waiting for, and I'm working hard to just make sure that whole system is going to be nice and easy to use. So while Fugio is primarily a visual programming system, I don't think it's a good idea to sort of force everything into using like nodes. I mean, we could do it, and then we could have like hundreds of nodes all over the place, and just to sort of make it try and fit into that structure. But I think it's a much better idea to accept that we're going to need to do a little bit of programming here and there. So we have the option to, where it makes sense to have code, we can put code in. Now we're going to be using a language called Lua, Lua. A few of you might have heard of this. It's actually quite a widely used language. It's used a lot in gaming, and because it's very, very fast. It's much faster than Python or PHP, and I've used it for running various things for years. So I'm quite used to it. I know there's a lot of people out there who like Python and things. I've sort of started working on a Python plugin, but it's certainly not as well developed as the Lua one. So I hope that you'll see that it's very easy to sort of get into. There's a lot of support for it. It's been around for many years. So let's see how we can integrate this into Fugio. So the first thing we're going to need to do is actually install Lua. Whereas the previous plugins have just been self-contained, they've had everything they needed to run. The Lua plugin is the first one that will need you to actually install the additional software. If you just download the new version of Fugio and run it, it will run, it will load, but it won't load the Lua plugin, and you won't have the new Lua node. So the first thing we want to do is install it. Now I'm going to set up a wiki page, so it will be wiki.bigfug.com/Lua. And I can sort of point you in directions of where you need to go. But we're going to firstly look at the sort of recommended place to get it, which is a website called luarocks.org. They do a sort of nice pre-packaged system for installing extra functionality for Lua and Lua itself. So Lua can be used for doing JSON processing, or there's lots of other sort of modules for it. It's got information for installing it on Windows and OS X and Linux. We're just going to be looking at OS X here because that's what I'm recording on, and we're going to be I've done all this, so but basically I recommend using the Homebrew option. You can download Homebrew from brew.sh, and it allows you to add extra functionality to OS X relatively easily. You might need to download the Apple Xcode, which is a pretty big download. But it's kind of unavoidable. I'm afraid going forward we're going to be using more modules and using more third-party libraries where it doesn't make sense for me to distribute them to you. It's much better that you install them on your machine. So I can recommend installing this. You could also use Mac ports if you want, but you'd have to change the destination. And finally, if you feel like it, you could install the Lua binaries off luabinaries.sourceforge.net, where you'll manually copy them across. So again, I'll put some extra. Any questions you have, let me know. I'll put any help in the wiki page. So let's jump forward. We've got Lua all installed, and I'm just going to create a new patch now. I've done a couple of examples. Under the example menu, you can see I've started to add a couple of little tutorials here. So we're going in this tutorial. We're going to create the inputs and outputs tutorial patch there from scratch. So I'll show you exactly how to add pins and work with things. So the first thing we're going to need is a text editor, and this is one of the new nodes from that we've added in this release. So we double click and we type in text editor. There we go, and we get this additional window popping up, which is very simple. It's a visual text editor, I use this for doing Lua, and also we'll also use this for doing OpenGL shaders later on. So the next thing we want to add is the Lua node itself. There's only one node, and when you add it, you've only got a single pin, which is the source code. So we're going to link the output of the text editor to the input like this, and we are now editing the source code that will be passed to the Lua script. So the first thing we need to do is we need to add the built-in Fugio library into our Lua program. So the way we're going to do that is type in this line of code, which is you're going to probably have this at the top of all of your programs, and it basically means we're requiring the Fugio library, which is built in. The next thing we want to do is we want to add our main function, and this is the one that Fugio will call when the program is run, and we want, just for this very first example, we're going to call the log function. Like this, and what this is doing is calling the log function of the Fugio library and passing it this string, which is hello world. So this is our Fugio hello world program. Now, when you're editing in the text editor, the changes are not being sent to Lua as you type. It's not a live coding environment. In order to update that code, we need to press the update button down here. And if we scroll down to the bottom of the logger window, we can see we have now got hello world, which is the string that we've printed out. So we know it's working. It's all there. So this is basically the first tutorial sort of patch that I've supplied, but it's got a bit more commenting and a bit more information about what's going on. So let's update this, make it a bit more interesting, and basically build the second tutorial patch, because obviously this Lua node is just operating entirely in its own little bubble. It can take inputs and it can produce outputs, but that's all it kind of knows about the world. So the first thing we want to do is add an input. So I'm right clicking or control clicking onto the node, and we're going to go to add input pin. And I'm just going to give it a name of input 1. Press return, and there's our pin. I'm going to add another input pin, and we're going to call that input 2. And finally, I'm going to add an output pin, which is going to receive the result of our code, and we're going to just call this output. When I do this, you'll also see that because it's the output pin, you have to choose the type of pin that it is. And these are all the different kinds we can set. For the moment, I'm just going to choose float, which is a floating point number, and it means that we're going to output a number from this node. So okay, and there is our output pin. And if I roll over it, you can see that it's a float and it's currently at 0, which is to be expected. Let's add a little LCD node there and link that up so we can keep an eye on this number, this result. And finally, for the visual part, I'm going to add 2 floating point inputs, there and there. You'll see that Hello World is appearing because every time you update an input pin or connect an input pin, it triggers the code again. So it triggers the code within the main function. And I'm just going to change this to 5 and this one to 7. So this is all the sort of visual setup that we're doing. So now we need to go back to the code editor, and the first thing that we want to do is we want to get access to those pins that we've just added. So the first thing we'll do is create a variable called pin input 1, and we call the Fugio function input. So what we're doing here is we're getting the input that is called input 1, which relates to this pin here, and storing it for later, because we're going to read from that pin. And I can just copy and paste that and get input 2. And obviously we also want our output pin, and this time we call the output function. So the name here has to match up with the name on the pin, and you also need to, you can't have like 2 pins called output, which is why I've got input 1, input 2. They have to have a unique name. So this is all the kind of setup we need. Basically, when you if I now update the code, this code is being called straight away. So it's like setup code. So our setup code is loading the Fugio library and accessing these pins ready for us to process something. Once it's called the setup code, it will then call the main code in the main function. And every time we update the inputs, it just calls the main code again. It doesn't call the setup code unless you change the source code, if I update the code in the text editor. Now, obviously, we want to get rid of that line of code because we want to do something a bit more interesting. So we want to get the actual number that's connected to this pin. So I'm going to add a couple more variables, which is input 1. I call it local here because it means it's just in this function. It's not. I can't access it anywhere outside of the function. It makes the code a bit more clearer in terms of general overall structure, but don't worry too much about it at the moment. And we want to get the value of pin input 1, which is done by calling the get method. There's a slight difference between methods and functions. Again, don't worry too much. But functions have a dot, and methods have a semicolon. To begin with, you'll probably find that you're just sort of copying and pasting this stuff. So, but if you read up a bit more about Lua and how it works, you'll learn the differences. Again, we can copy and paste that, and we're going to get the other number in input 2. So we're just going to do something really simple. We're just going to add these two numbers together, and that will be our output. So let's say our result is input 1 plus input 2. Now we want to set the output pin to be the result of our processing, the addition. So pin output semicolon set result. So that's setting the value of the pin, the floating point value of the pin, to the result here. If I update this now, see, it doesn't print hello world anymore. Instead, we've got the number 12 in our output, which is 5 plus 7. If I change this to 10, you immediately see that it's updating. So every time I make a change, it's now calling this code again. So I can change this number 2, change that to 10 as well, and we've got the result, which is 20. So this is obviously a very trivial example of what you can do, but it should. I hope it's enough to to give you an idea of how you could use it to take custom input, do custom processing, and produce the outputs you need. I was using this when I was testing some open sound control stuff that we looked at last week. There's a program which uses the touchpad, but it produces this quite complicated open sound control message, which I used Lua to actually process. So it takes the input from the open sound control and breaks it down, and means that I can sort of use it in a more in an easier way. So Lua is like kind of glue. We can use it to do simple tasks. It could be like a sort of custom processing on input data like we're doing here. But you can use it to write whole complicated things as well. So I've used it for installations where you want to do sort of interactive work, so you can get data from cameras or tracking things, process it in Lua, and then produce data that's then turned into visuals on the other side. And it's pretty fast. It's a really good language to learn. So I hope that's sort of whetted your appetite to see kind of how this is working. So the reason why I wanted to introduce it is because in either next week or the following week, I'm going to start introducing some visual programming, and we'll actually be using Lua because it makes a lot more sense to, if you're drawing lots of multiple elements and things, then you want to use a very, you can use programming to make it more succinct rather than having lots of nodes and things. So we're actually going to be creating graphics in Lua using this exact same process, but instead of outputting a number, we're going to be outputting an image, so yeah, so you can see how that works. Okay, so thanks very much for watching this, and hope you're enjoying the added functionality. Look forward to your comments and suggestions, and I'll see you next week when I'll be back in England, I think.